Okay, so I am doing problem 10.21, and that is asking me, a solid ball is released from rest and slides down a hillside that slopes downward at 65 degrees from the horizontal. A. What minimum value must the coefficient of static friction be between the hill and the ball surfaces have for no slipping to occur? And then would the coefficient of friction calculated in part A be sufficient to prevent a hollow ball, such as a soccer ball, from slipping? Justify my answer. And C, in part A, why did we use the coefficient of static friction and not the coefficient of kinetic friction? So, for part A, I'm going to be using the 65 degrees given, and then for position 1, it is at rest. And then I will be using the center of mass of the solid ball to be this equation. And then for a not slipping condition, I am going to be using equation given to us, which is 2/5 ma. Perfect. And then I'm going to want to find the friction of the y coordinate and of the x coordinate. So we're going to find where static of the coefficient of friction, if the friction force is greater than the ball will slip. So we're going to eventually have an answer that looks like this, greater, less than or equal to this. Perfect. And then I will have, by using these two equations, mg sine theta equals ma plus 2/5 ma, and then using this equation as well, where a equals 2/7 g sine theta. Plugging, and then once we plug in equations 1 and equations 2, we find that we can cancel out m using the x coordinate. So we eventually get that 2/7 tangent of 65 degrees will equal 0.61227, or about 6.613. And that is part A. And then for part B, I'm just going to repeat what I did for part A, but with a hollow sphere rolling down the hill instead. And so the center of mass for that is going to be which will equal 2/3 mr squared. And then for our not slipping condition, we have an equation given to us. And then once again, I do the x and y coordinate, cancel out the stuff from using the equations given to us, and we eventually get that 2/5 tangent of 65 degrees equals 0.8578, which is about 0.858. And then just to compare the static coefficient of friction found in part A for a solid sphere versus the value found in part B for a hollow sphere, we have, so remember that the one for the solid one is 0.613 and then the hollow is 0.858. So we get that the range that it will not slip is 0.613 less than or equal to the mu, 0.858. And then for part B, we use for part C, we use the coefficient of static friction in the analysis because of the not slipping condition required. There is no relative motion between the solid sphere and the hill.